That's better. Okay, so this is what we are going to do. Let me just make sure it's okay. So I don't collect the practice test and the practice quiz. Okay, so we are going to give it something. I will post something, we call it extra points. So the first one would be posted before your test. Then we collect that one and usually give you 4 points for it. Okay, but not practice test, practice quiz. So the practice quiz, practice test, because I'm already giving you the solutions. Okay, they are not going to be connected, but you will see extra one later today. And that would be something to help you for the test, and you can collect extra points, 4 points. Okay, let's go on. So we talk about derivative of the function, give you various definition, and but we arrive at the basic rules. So we are going to give you some example on that one. So just recall you, this is the power rule. Okay, this is the power rule. So the power rule is, if you want to find the derivative of a power of x, okay, x to the n. So we call it action of differentiation. Action of differentiation, you bring the power down, n down, x to the 1 down. This is n, is going to be n minus 1. Okay, this is the one we call it action of differentiation. That can be done for any, okay, for any number n. By number, we mean any rational number. Okay, let's warm up some examples to see how you operate, then we go to the main one. Okay, there you are, example. And we would like you to find the derivative of each function. Find the derivative of each function. Just give you some single one and we put them together to see how we're going to operate. Okay, there you are, the first one, f of x equal to x to the 5th. So this is just powers of x, and we have our formula here. So the solution is going to be, this is going to be f prime of x. You bring the power down, 5, x to the 5 minus 1. 5 minus 1 would be 4, and then we're done. Okay, any question? So just to remind you, so that's for the positive power, positive integer. We can have negative integers. So x to the negative 7. Okay, negative 7. So the solution is going to be action of differentiation, g prime of x equal to, bring the power down, negative 7, x to the 1 down. You see, 1 down means this is a negative 7. Negative 7 minus 1 would be negative 8. So it's going to be x to the negative 8. Any question? In your book, they go on, they change the negative power into the, into the fraction. That's optional. I don't do it for this type of function. We just a function as is. But if you do it, we don't mind. Okay, so we can have a positive integer, negative integer. So what is going to be the next type? And the next one, we can have some rational, some fractions, h of x equal to, for example, x to the 1/3. Again, action of differentiation. So the solution is going to be, we have the h prime of x equal to, you bring the power down, 1/3, x to the 1/3 minus 1. You see, 1/3 minus 1. It's going to be the same as 1/3 minus 3/3, or the common denominator. So on the top is going to be 1 minus 3. You see, 1 minus 3 divided by 3, which is going to be negative 2/3. So the power is going to be negative 2/3. Okay, Now, the shortcut that we are going to use is, look at this one, 1 dot, 1 minus 3, the top minus the bottom. 1 minus 3 is a negative 2. The numbers is going to be the same. Okay, we are going to do it quite a lot. So get used to it. 1 minus 3, negative 2, negative 2/3, and then we're done. Any question? So as you can see, we can do all sort of powers. Make it a little bit, one more of this fractional one. So that would be number 4. F of x equal to, you can have something like x to the 5, 6. Okay. So use that the short form that we talk about it. F prime of x equal to, you bring the power down, 5, 6, x to the 5, 6 minus 1. 5 minus 6 would be negative 1, negative 1, 6. Okay, 5, 6 minus 1 is that's 5 minus 6. 5 minus 6 is a negative 1, negative 1, 6. Any question? So we can all sort of powers. What's going to be the next case? The next case is, how about the negative fraction here? Negative rational number. So number 5. So number 5, you start with something like, how about the g of x? G of x equal to the x to the negative 2/3. Negative 2/3. Okay, the same thing, solution. So g prime of x is equal to, bring the power down, negative 2/3 x. Now negative 2/3 minus 1. Again, you see, negative 2 minus 3. You consider this negative for the top. Negative 2 minus 3 would be negative 5. So that gives a negative 5/3. Okay, it's the same as I talk about it, you see. This is it, negative 2/3 and minus 3/3. Again, that gives you negative 2 minus 3 would be negative 5. Negative 5/3. So that would be the final answer. So the fraction one is your challenge from time to time. Just make sure you are happy about it, the way we are going to operate it. Okay, any question? So what else? So how about so the different one is the next one, number 6. So let's see what is new about this one. F of x equal to 1 over x to the 6. You see, we can do only the powers of x. So over here is 1 over x to the 6. So what we are going to do, we are going to do a property of the algebra. We bring this one up. If you bring this one up, you change the power from the positive to the negative. Okay, so the solution is going to be, we don't like fraction in calculus. Anytime you see it in this course, move it up. So it's going to be f of x equal to the x to the negative 6. Okay, so to remember this formula, if you have 1 over x to the n in this course, move it up. It's going to be x to the negative n. So make a note of this formula and use it all the time. Okay, any question? Now the result is going to be what? F prime of x equal to negative 6 down, x to the negative 6 minus 1. Negative 6 minus 1 would be negative 7, the final answer. Again, at this level, I don't change it to get back to the, to the fractions. You can do it for yourself if you like, but you don't have to for these type of problems. Any question? So we take care of any power. Okay, any powers. Now, if you have a power function down the denominator, you just move it up because we don't have any other formula. You move it up, you make it to the x to the negative 6. Now negative 6 down, negative 6, x to the negative 6 minus 1. Negative 6 minus 1 would be negative 7, and we are done. Okay, so going to the next page and continue. We have some other powers to take care of, and then we arrive at there. Now, what's going to be the next one? The next one is going to be again the special one. We took care of the fractions, if you like, but how about the radical function? You see, number 7. Number 7 is this one: f of x equal to the cube root of x. You see, we cannot do the radical. We can only do the power function. Any suggestion? Do you remember how we're going to change this one into the power function? Or if you change it, it's going to be equal to the x to the what? What power?
X to the 1/3.
X to the 1/3. Very good. Yes. So we don't like radicals in calculus. Anytime you see the radicals, we are going to change it. I'm going to give you the formulas. So this is the solution. So we are going to use this two famous formula through this course. You see, if you have the n root of x, this would be x to the 1/n. Okay, anywhere in this course, you see the radical, switch it right away. And of course, if it's going to be radical x, you know that the index is 2, so that would be x to the half. Okay, and if the most general one is this, if you have the n root of x to the m, it's going to be x to the mn, you see, because this index would goes down the denominator. So that gives you m/n. So make sure you remember these formulas. And anytime in this course, anywhere in this course, you see a radical function, switch it right away. Okay. So getting back to this, now we switch it first, rewrite it, x to the 3rd. Now we can do it. Okay, we can do it. So f prime of x is going to be equal to, bring the 1/3 down, 1/3 x to the 1/3 minus 1, 1 minus 3, negative 2/3. So that gives you the final answer. Okay, so no radicals, no fractions, if you like, in calculus. Anytime you see it, switch it. For the rational function, you move it up. For the radical function, you just switch it into the rational power of x. Okay, a little bit more general one, and this is number 8. We have h of x equal to, suppose you have a 5th root of x to the 4th. Okay, again, you have to switch it right away. So the solution is going to be, this is it, solution. We rewrite it, so that gives you h of x equal to the x to the, okay, rewrite is going to be x to the 4/5, x to the 4/5. Okay, and now we can do it. Remember, the indexes goes down the denominator all the time. So h prime of x, you see h prime of x is going to be equal to, bring the power down, is going to be 4/5, x to the 1 dot. 4/5 minus 1, 4 minus 5. 4 minus 5 would be negative 1. Negative 1/5 is the final answer. Okay, any question? The other one is, this is the most general one that we're going to have, and some people, they missed it. What is special about this? It's going to be f of x equal to the 1/5th root of x. You see, you have a radical function, and at the same time, you have a radical function. So what we are going to do is we have to change the radical first. You change the radical, 5th root of x would be x to the 1/5, and then you move it up. So I do it in 2 steps, but you can do it right away. So rewrite it first. is going to be f of x equal to start with, it's going to be 1 over x to a fifth, but you have to move it up. It's going to be x to the negative 1/5. Okay, we do it usually right away, but make sure you do it. Some people, they miss it on the test. They do it right away. They write a positive. It's not. It's going to be negative 1/5. And now we can differentiate it. So f prime of x is going to be equal to you bring the negative 1/5 down, negative 1/5 x to the negative 1/5 minus 1, negative 1 minus 5 would be negative 6. So that gives me negative 6/5, the final answer. Any question? Now, for the radical x, there are a number of applications that we're going to use. So I write this radical x, a special one. You will use this notation because there are some application problems. It's not a big deal, really. There are some application problems in the future that we're going to do it. So I make a note as if f of x is going to be equal to the radical x only. Okay, you know that you have to switch it. Solution. So f of x is going to be x to the half. Okay, now if you differentiate it, f prime of x would be 1/2 x to the 1/2 minus 1 is a negative 1/2. Since we are going to use this one quite a lot, so I'm going to simplify it, and you can memorize that simplification is simplified form for future. If you want to simplify it, this is it. You have to change it to the fraction first. It's going to be 1 over 2x to the half. And x to the half would be radical x. So 2 radical x. So you better memorize this one. That would be useful for you. But again, you don't have to. It would be fine. You can do it. So the derivative of radical x is simply 1 over 2 radical x. Okay, this would be useful because we are going to have trigonometric function, and we don't like to end up with this type of results. Okay, so just for the radical x, you better simplify it and write it down in this format in those application problems. But for the time being, if you don't change it, you are not going to be penalized, if you like. We are not going to take any points out if you just stay with this one, but for future. Okay, any question? So these are the warm-up. Okay, of course, we have to differentiate, polynomials, rational function, which are going to be more involved. Okay, so in order to be able to do those type of problems, we are going to study a couple of more basic rules of differentiation, and then we'll be able to do the actual one. Okay, so we continue with the rules. We give you a couple of more rules. Any question? So I just use the power rule to do this, but these are just the warm-up. So what's going to be more rules that we need? So this is going to be 2.2 officially. They talk about basic. Okay, basic rules of differentiation. That with the basic rule, you'll be able to do the derivative of any polynomials. Then we give a couple of more before the test, and then you'll be able to differentiate most of the functions. Okay, so in order to be able to differentiate a polynomial, you are going to need the following. Okay, are you ready? The first one. The first one, a constant function, if f of x equal to the c. F of x equal to the 5, f of x equal to the 7, if this is going to be the case, is a constant function, is a constant function. You see, that's going to be one. Then you can use the derivative formula to prove the f prime, or you see if you have a constant function. Suppose you have f of x equal to 5. What is the graph of y equal to the 5? Any suggestion? Graph of y equal to the 5. You say this is going to be y equal
Just
to
a horizontal line.
excellent horizontal line. What is the slope of a horizontal line?
Nothing. 0.
You mean 0. Yes, the slope is 0. But you know that the slope and the derivative are going to be the same thing. Remember, if the function is differentiable, the slope of the tangent line is going to be the same as the derivative of the function. So if you have a constant function, this is the constant function. The graph of the constant function is going to be a straight line, and the slope of the straight line is 0. So this means the derivative of this function is always 0. Okay, then f prime of x is equal to the 0. It can be proved by the formula, but just something to remember. For all x, that's it. So if you have f of x equal to 5, f prime of x would be 0. F of x equal to the radical 2, f prime of x would be 0. Okay, so if you have a constant function, derivative of a constant function is 0. You can use the derivative formula. Remember, the top is f of x minus f of a. So it would be c minus c, which is 0. But to remember it, the graph of the constant function is a horizontal line. And the slope of a horizontal line is 0. So the derivative of a constant function is 0. Any question? That would help us when you want to differentiate a polynomial. The derivative of a constant part would be 0 right away. The second one, we already talked about it, but we have it here officially, the power rule. Okay, that is the power rule. So the power rule is going to be derivative of x to the n is nx to the n minus 1. Okay, so we did this one for any number n. Okay, that's a power rule. The third one is if you multiply a function by a number. You see, you have the function, you multiply by 5. So if you want to find the derivative of 5 times the function, it's going to be 5 times the derivative of the function. Okay, this is a property that eventually will tell us that the derivative of the function is kind of, we call it the linear function or the linear operator. So this is going to be the case. So if f is differentiable, if f is going to be differentiable and k is a number, k is a number, then k times f, twice, 3 times, 4 times, is also differentiable. Okay, differentiable, and the derivative of k times f of x is going to be k times f prime of x. That's it. This basically means that the coefficients stay unchanged when you differentiate. You see, if you differentiate 2x to the 5th, it's going to be 2 times derivative of x to the 5th, which is 5x to the 4th. Okay, so any constant stay unchanged. So that is going to be the third condition. Okay, any question? The only other part that we're going to consider to be basic is this fact that if two functions are going to be differentiables, then their sum and their difference means f plus g and f minus g are also differentiable. So if you put all these together, then we get the fact that each polynomial are going to be differentiable, okay? So if you be given two functions, so if the functions f and g are differentiable, okay, differentiable, then the functions sum function f plus g and the difference function f minus g. Okay, these functions are also differentiable, are also differentiable. Okay, they are going to be differentiable, and we have the addition rule or a difference rule, if you like. So if you want to differentiate f of x plus g of x prime, you differentiate the first one and you add it to the second one. So that will help you when it's a polynomial. Okay, and for each differentiation, you are going to use just the power rule to operate it. So it would be the same for the difference because of this. So f of x minus g of x prime is going to be f prime of x minus g prime of x. You see, they call it addition rule and difference rules, okay? Or just addition rule for the derivative of the function. It's very easy to prove. You just write the definition of the derivative, and you already got this idea that if you want to find the limit of a sum of two functions, it's going to be limit of the first one plus the limit of the second one. You see, when you write the definition for the derivative, it's going to be the sum of two limits. The first limit would be f prime, the second one would be g prime. So it's not a big deal to prove it. Okay, so this is going to be basic rules of differentiation. There are a couple of more. We are going to talk about it step by step. But knowing this would help us to be able to answer kind of 3 problems for your tests. Okay, so the first problem is going to be evaluation of the derivative, just using this one. Then we are ready to solve the problem of a tangent line in a short form. Remember, no more application of the definition. You're just using these rules to answer your problem. And then the application problems in physics and everyday life. Okay, so 3 to 4 questions on that test coming from these theorem, and I'm going to give you one from each. Okay, so the examples that I'm going to do are going to be repeated on the test, or the similar one. Okay, so let's do it. What is going to be case 1? So example number 1 is finding the derivative of the function. We give a couple of functions and we ask you to differentiate it. Okay, are you ready? So study these examples for the test. This is the first one. And you have a similar one on your practice test. You can check it. I'll post your extra points number 1, which is very similar to the test. And then you will see one problem on that one too. Okay, so find the derivative. So that extra 1, we call it, is going to be posted. You do it, upload it to the canvas. For each extra 1, you get 4 points. There are going to be 5. We don't give you extra 1 for the quizzes. We just give you extra for the test. So it's going to be 5 times 4, 20 points, which is quite a lot, for your final grade. So make sure you don't miss it. And it's going to be due on the day after. It's going to be due next week, probably Tuesday. Okay, I posted for you. So find the derivative. Find the derivative of each function. Each function. And you are going to use the power rule to get this true. Okay, the most common one is the first one. The first one is polynomial. F of x equal to 5x cubed minus 4x squared plus 7x minus 10. You see, it's a polynomial function. It's a combination of powers of x. Of course, this is a polynomial. All the powers are nicely given to you, but in general, in this, you may get a combination of various powers. So if there is going to be any radical function, radical powers, you change it, or radical expression. If you see any quotient function, you are going to change it at this level because we have only the power rules to take care of, okay? So this is it. This is going to be the solution. We use the power, I just explained this first one, but then I give you the short form. So if you want to differentiate this function, you differentiate each one of them separately according to this addition rule and the difference. So I just write it down. It's going to be derivative of the first one, you see, minus derivative of a second one, plus derivative of a 7x, minus derivative of 10. Okay, derivative of 10. Okay, now we use the power rule. So f prime of x is equal to, now the power rule now is going to be exponent times coefficient, 1 dot. Because we talk about it, the coefficient stay the same. 3 times 5, 15. 15 x to the 1 dot, 3 minus 1, 2. That's the derivative of the first part. Any question? We just keep going. Minus second one, the same thing. Exponent times coefficient, 2 times 4, 8. 8x, 1 dot, 2 minus 1. Plus exponent times coefficient, 1 times 7 would be 7. 1 down, x would disappear. Because the power of x is 1. 1 down means 1 minus 1 would be x to the 0. X to the 0 is 1. We don't usually write the x to the 0. Okay? 1 times 7, 7. 1 down, x would disappear. Minus derivative of 10. 10 is the number, a constant function. Remember, derivative of a constant function is 0. So f prime of x is going to be equal to the 15 x squared minus 8x plus 7, and you're done. So don't make it complicated. In some books, they use the notation, different notation, d by dx, etc. No, that's it. Even we are going to make it shorter. Okay, even we are going to skip this part. We do it right away. Any question on this one? So short version. This is the way we want you to do it on the test for us, okay? So I give you a similar one. G of x equal to x to the 4th minus 18x squared plus 7. We're going to see this function several times in this course. You see, this is the way you're going to do it. Solution. You check to see if there is any radical, you switch it. You rewrite it. If this x and the power of x are going to be down the denominator, you move it up. So for this one, it's already done. So differentiate, go forward. G prime of x equal to derivative of the first one. Exponent times coefficient. 4 times 1 is 4, 1 dot, 4x cubed. It's done. Okay, continuing with the second one. 2 times 18, 36 minus 36, 1 dot x. Derivative of 7 is 0. And you're done. Okay, this is the way we want you to write it down on the test for us. Any question? So that's the one we call it type 1. Type 1 because there is no rewriting, okay? No radical, nothing. Ready for the next one? This is the type that you will see on the test. A little bit more job to do. So what's the function? This is the function. H of x equal to 6 radical x, okay, minus 5 over x cubed plus 8x minus 12. Let's see a kind of most general one that we can have. So you have a look. You see the radical here. You have to rewrite it. Radical x, x to the 1/2 if you like. Over here, you see the x cubed on the denominator. You have to move it up. Okay, so you do this extra job first. So the solution is going to be, so h of x is going to be 6 x to the half minus 5 x to the negative 3 plus 8x minus 12. You see, that's your first job. So your first job is you are going to rewrite it if it is needed. In this case, we do need this because this is a radical x, so it's going to be x to the 1/2. X cubes down the denominator, just move it up, 5x to the negative 3, and that's 8x minus 12. You haven't done anything, you just did the algebra. Now differentiate. H prime of x equal to action of differentiation, exponent times coefficient, 1/2 times 6. I write it down, then I simplify it. You can do it right away if you like. 6 times 1/2 x to the 1 down, 1/2 minus 1. Remember, 1 minus 2 is a negative 1. Negative 1/2. That's the first one. Continue. Next one, exponent times coefficient, negative 3 times negative 5. Negative 3 times negative 5 would be positive 15. So that give a plus 15. 15 x to the 1 down. That's a negative 3 minus 1, which is going to be negative 4. Negative 4. Okay. Then the next one, 1 times 8 would be just 8. 1 down, you know that. X would disappear. And derivative of 12 is 0 because 12 is a constant function. Any question? So 1/2 times 6, 1 down, x to the negative 1/2. Negative 3 times negative 5, positive 15, x to the 1 down. Negative 3 minus 1, negative 4. Derivative of 8x, 8. And derivative of 12 is 0. But you have to simplify if anything is needed. H prime of x equal to, so we simplify this as 6 and 2. So that gives us a 3. So the final answer is this one, 3x to the negative 1/2 plus 15 x to the negative 4 plus 8, and be done. Okay, as we'll talk about it, some people, they go on and simplify those negative power, but in this course, we don't need it. Or at this point, we are not going to do it. Any question? So this is a kind of problem that you should be able to do for us for this section. Okay, and I give you one more. This is the kind of most general one. And I give you a few minutes to see if you can do it yourself. So what is this? You say this is the kind of most complicated one that we can have so far. F of x equal to the 6 cube root of x. Okay, some people, there are some points here, they missed it. 10, okay, fifth root of x to the 4th plus 12. Okay, just give you a couple of minutes to see if you can do it yourself, then we check the solution. You know that you have radicals all over the places. So the thing that you have to do is you have to check these radicals. You have to rewrite it first and then start differentiating. Try to see. Okay, anybody got the answer to this one?
I think I do.
Okay, read your answer.
2x to the negative 2/3 minus 8x to the negative 9/5.
Excellent. That's it. Yes, you are right. So let's check it. Yes, very good. Okay, so this is it. You have to do the rewriting carefully. So this is going to be f of x equal to 6x to the, you see 1/3, 1/3 plus 10x to the, you see down the denominator would be 4/5, but you have to move it up at the same time. So it's going to be negative 4/5. This is the one that some people, they miss it on the test. Okay, this radical is up there, so the power would be positive. But this radical is down the denominator, so the power would be negative. Make sure you don't miss it. So it's going to be x to the negative 4/5 plus 12. Okay, now we differentiate it. So f prime of x is going to be equal to exponent times coefficient, 6 times 1/3 x to the 1/3 minus 1. 1 minus 3 would be negative 2. So we get the negative 2/3. Okay, plus 10 times, you bring the power down, negative 4/5 x to the negative 4/5 minus 1 is like negative 4 minus 5. Negative 4 minus 5 would be negative 9. So that even negative 9/5. Okay, the derivative of 12 is 0. Okay, exponent times coefficient. 1 down, 1/3 minus 1, negative 2/3. This is down the denominator, so the power would be negative. Now we have to simplify this fraction if we can. So this would be simplify. So f prime of x is going to be equal to, and so that give you 2x, okay, 2x to the negative 2/3. Then we get a chance to simplify the 5 and the 10, so that give you 2. 2 times negative 4 would be negative 8. So it's going to be minus 8 x to the negative 9/5, the final answer. This is the most involved problem that you may see in this, in this section. 2.2. You get it quite a lot in your books. So check the assignment of this one. You see the assignment that are posted when we say homework 1. Those numbers, those sections refer to your book. So there is no direct link to the problems because I cannot post the problem from your book because of the copyright. Okay, so the problems, the links are given to you and the numbers are given for your homework. And you have to go through your book and pick the problems from there. Okay, so that would be our final answer to take care of it. Any question? So we did the first problem. Okay, so this is going to be our first problem for the time being and first problem for your test. Just finding the derivative of the function. What next? Quickly, of course, tangent line problem. And remember, we talk about it. We would like to find the equation of a tangent line. Now we know that the slope is going to be the derivative. Previously, for the derivative, we have to use the definition formula, but now you don't need that. We can do it by just using the derivative of the function, okay? So that would be your second problem that you have to know for this test or in this section. Okay, so that was example 1. Then quickly check, as I told you, those practice tests that we have. So this is going to be our second problem example. But second problem is the equation of a tangent line. So what is going to be there? So the equation of a tangent line. There are kind of 2 parts or 2 problems on the tangent lines. This is one of them. So a nice a polynomial type at this level, we can give you only polynomial for this problem. So find the equation Okay, find the equation of a tangent line. Equation of a tangent line to the graph. Okay, to the graph of this function of function f of x equal to the x cubed minus 3x plus 1 at a point, or at the point with the condition of x equal to -1. That's it. So we want to write the equation of a tangent line. Okay, equation of a tangent line to the graph of this function. You know that you need a point and the slope. Point x value is given to x equal to -1. You drop it into the function to get the y value. So that makes a point. Then you need the slope. This is calculus. The slope is the derivative. You differentiate the function using those power rules formula that we talk about it. You evaluate the f prime at -1. So you plug x equal to -1 into the function to get the point. Plug in the derivative of the function that give you the slope. So you have a point and the slope, you write the equation of a line, and then we're done. Okay, so that is tangent line problem. So we previously, remember, we find the slope by using the limit formula, but no longer we are going to use those type of methods. Okay, so just don't do it. So that's it. The solution is going to be, I need a point, just remind you. So for the point x is given, so drop it into the function. So f of -1, carefully, is going to be -1 cubed minus 3 times the -1 plus 1. -1 cubed would be -1. So that gives you a +3. Okay, a +3 and a +1. So -1 cubed is going to be -1. So we simplify it, that gives us 3 here. Okay, so that's it. The point, we call it the point P. The coordinates are going to be -1 and 3. This is the point. Any question? Next, we need the slope. So what's going to be the slope? This is calculus. The slope is the derivative. F prime at what? At -1. So that would be the slope. So in order to do it, we are going to use the derivative differentiated. Just use the formula that we have. So f prime of x is going to be equal to, this is your function, exponent times coefficient, 3 times 1, 3, 1 down, 3x squared. Then minus 1 times 3, 3, and the x would disappear because 1 down would give you x to the 0, which is 1, and derivative of 1, of course, is 0. Okay, so evaluated at -1 again, f prime of -1 would be 3 times -1 squared minus 3. Okay, -1 squared is a +1, so that gives you 3 minus 3. 3 minus 3 is equal to the 0. So f prime of -1 is equal to the 0. So this means the slope is 0 in this case. That's it. So we have the point. You see, we have the point. The point is -1 and 3. And you have this slope, which is 0 in this case. So write the formula, y minus y1 equal to the m times x minus x1. You have to substitute and simplify. Y minus 3 here. Okay, that gives you y minus 3, and the m is 0. 0 times x minus x1, negative. Since this is 0, so that gives you y minus 3 equal to the 0. and the slope, then the line would be y equal to 3. It's a horizontal line in this case. Okay, so that would be the equation. So you have to simplify your result. The equation of the tangent line, of the tangent line, and you down. Okay, so that would be our second problem. When we get more information about the derivative of the function, we are going to have this problem again. But for the time being, we can only use the kind of a polynomial types to be able to find it. Okay, any question? So this is going to be a kind of a part one of the definition, the tangent line problem. You are going to have another property of the tangent line that we're going to check it. Okay, let's do that one too. So that's problem number 2, or the concept number 2. So we usually give you one problem, 2 parts of the tangent line. This is the first part. So what's going to be the other part? You see, this next part is we prepare you for future. Is in future, we are going to be very much interested on the horizontal tangent lines. Okay, so this is going to be our next example or your next questions that you're going to have. Okay, this example is getting much more involved in future. So what is going to be horizontal tangent line? Okay, horizontal tangent line, tangent lines. Okay, let's talk about this horizontal tangent line. I drop this example so I can explain this one first, okay, because it's very important. We can not talk about it now because this is going to be used in future, but we prefer to talk about it, and in future we are going to use it. You see, what we are going to do after learning the derivative of the function, we're going to do a kind of so-called optimization problems. Optimization problems mean we are going to be interested in finding the maximum and the minimum value of a function. So for getting those max and the mean, you have to find out where on the graph of the function this would happen. Look at this one. If this graph is given to you, look at this. If this graph is given to, this graph would peak at this point. So that gives us a maximum. And that would be the minimum in future. In order to find it, one way to look at it is to look at the tangent line at these points. As you can see, the tangent line at these points are going to be horizontal. So this is going to be horizontal, and this is going to be horizontal. So that will tell you that in order to find those maximum and the minimum in future, you have to find out for what value of x these, okay, the tangent line at this point is going to be horizontal. Okay, what's the slope of a horizontal line? Any suggestion? When we have
0.
0, you know that because there is no rise. So the slope is 0 over here, okay? The slope would be 0. But this is calculus. You know that in calculus, the slope of a tangent line would be the derivative of the function. So this means at this point, there is going to be an x such that f prime of x is going to be equal to the 0. So that will tell you how we're going to find it. It's going to be the same thing for this one. You see, the same thing for this one is f prime of x equal to the 0. So that gives you a tool to be able to find out for what value of x you may have a maximum and the minimum in future. But we want to practice because you have to solve this equation. And we want to be ready for it in future. So that's why we bring it right now up and we check. We are not going to ask you to find the maximum minimum, but we are going to ask you, find the values of x. Find the values of x where the tangent line to the graph of the function, and those values are going to be horizontal. So basically this means you are going to find the derivative of the function, you let it equal to the 0, you solve that equation. That equation gives you those values that you're going to be interested in. In future, these values are going to be referred to as a critical values. And this is the one that we call it 50%. Because for all the problems of this next chapter, everything you want to do, you have to find these points first, and you get 50% of grade for each of those problems. So that's why we want to bring it up in front right away to practice for it, okay? So just give you a hint, and then we are going to do the first part, okay? So that's the purpose. We can ignore it and talk about it at the next chapter, but we don't, because we want to, to polish your algebra before getting to that. So I recall that I just explained when I talk about it. Recall that if f is differentiable, differentiability in calculus means there is a tangent line. Existence of a tangent line and differentiability are the same. So recall that if f is differentiable at x, remember then f prime of x can be considered as a rate of change in physics, but the slope of a tangent line in geometry. Then f prime of x is the slope. Okay, it's going to be the slope of a tangent line, the slope of the tangent line to the graph of the function, okay? To the graph of your function, graph of y equal to the f of x at x. Okay, this is the one that we know it. Anytime in calculus, you say tangent line, you mean derivative. If you say derivative, you mean tangent line. Okay, now, as I explained it, therefore, if the f prime is 0, therefore, if f prime of x is 0, okay, if f prime x 0, this means the slope is 0. When the slope is 0, the line is horizontal. So if f prime x is 0, then if you like, the slope of a tangent line would be equal to the 0, and the tangent line is horizontal. The tangent line is going to be horizontal. Okay, so this is going to be something that you have to keep in mind for the rest of the course, that if you want to check the possibility of at this level, we say tangent line. But when we get to the next chapter, we say, oh, critical values. So the critical values would be, again, those values of x that satisfy this condition for you, that satisfy the fact that f prime of x equal to is going to be equal to the 0. Okay, so we give a function and we ask you the question. Find the values of x where the tangent line is going to be horizontal. So you simply find f prime of x, you let it equal to the 0. That's it. And then you're done. And in case of the trigonometric function, this would be a very interesting problem. We talk about it later. So you get one question on this, 2 parts. The first part is a polynomial type, the second part, trigonometric type, but do the polynomial first. So this is going to be our example. Quite an important problem, okay? Again, for future. That's it. Find the values of x values of x where the tangent line, where the tangent line or lines, okay, to the graph of the function to the graph of the function. Okay, or horizontal. Horizontal. That's it. So I'm going to give you this function. Again, this is the one we're going to use several times. So get to know it. X to the fourth, 18x, I think is squared, plus 1. It's a kind of example that you're going to see several times in this course. Because even when you get to the next chapter, we don't ask you find the values of x. We just ask you find the maximum, the minimum value of the function. So the first part would be the same thing. You have to find this x. Okay, so you know what to do. We already talked about it. The tangent line is going to horizontals if f prime is equal to 0. So basically, to solve this problem, the only thing that you have to do for us is going to be the following. You are going to solve the equation. Solve the equation f prime of x equal to 0 for x. That's it. Because we already talked about it. We already talked about it that the tangent line is going to be horizontal if the slope is 0 and this is the slope. Okay, any question? Differentiate. Easily differentiate. What is the derivative of this function? Anybody wants to try?
4x cubed minus 18 or 36x.
Excellent, that's it. 4x cubed, yes, very good. 4x cubed. Exponent times coefficient, 2 times 18, 36, 36x. Derivative of 1, of course, would be 0. Very good. Okay, just let it equal to 0, solve it. So f prime of x equal to 0. So it's 4x cubed minus 36x equal to 0. You have to solve this equation. Any suggestion? How can you solve this equation? This is where you want to practice, to make sure that you are ready for it.
We factor out a 4 and an x.
Excellent, that's it. Factor out the 4x. 4x out, so that gives us x squared minus 9. You see, we can handle this one, x squared minus 9. You can factor it as well if you like. So it's going to be 4x times x minus 3 times x plus 3 equal to the 0. Okay, now we have 3 factors, 1, 2, 3. You let each one equal to 0 and you solve for x. Okay, the first one for x equal to 0. For x equal to 0, x would be 0. You know that x would be 0 over 4, which is 0. So one of the values is 0. Okay, and do the other one, x minus 3 equal to 0. That gives you x equal to 3. Okay, and the x plus 3 equal to 0. That would give us x equal to -3. So you are going to have 3. We call it, in future, use this notation. Not bad if you want to use it from now on. In short, we say the critical values are going to be 3 numbers, -3. Okay, we have a -3, 0, and 3. Just get to know this notation for future. Okay, so this means you are going to have 3 horizontal tangent line. In future, at this point, you get your maximum and the minimum for this, for this graph. So, and that is, if you graph it, I think it's going to be something like this. You see, this is going to be a kind of graph that you're going to have. So as you can see, you have 1, 2, 3 horizontal tangent line. And in future at x equal to 0, that give you the maximum value. At -3 and 3, that give you a minimum. So this function would have a minimum value at a -3 and 3, and the maximum value at 0. So that's our target in future. Okay, so we can leave this problem and talk about it in future, or we prefer to do the algebra now. So this is going to be 50% of most of the problem when we get to the next chapter. Okay, get used to it. So we give you one on this in the quiz. It's going to be 2 parts, polynomials, and we want to check your your knowledge of a little bit tricks function, and we do that one later. So pay attention to this type of problems for future. Okay, it's going to be quite a lot that's going to be talk about it. So that would be our. So now we finished with the problem of a tangent line. So it's a one problem, but 2 parts on the test. You see, the first one is straightforward. Find the equation of a tangent line for us. It's going to be polynomial types. But the second part, or the second problem really, is this one, that find the horizontal tangent line, which is quite important for us. And you have a couple of problems in your book. Just pick those, write the equation, make sure you are able to solve this equation. Okay, sometimes you may have to use quadratic formula to get this done. So it can be done mostly by direct factoring, but check it, the one that you have in your book, to make sure you are ready for it. Okay, so that is the problem of tangent line. We have 2 more to go. So let's have a break, and we come back and we take care of the other 2 are going to be application problems in everyday life. Okay, so the one that we suggested the other day, but we give you the results. Now we go back, you are going to do it yourself, those problems of the rate of change. Okay, and so going to be application problems in calculus, going to be easy one, and this is the one that you enjoy really. We don't do any application problems, so what's the point? Okay, so get to know to like them, and you are going to use it in your research. Okay, so it's a 9:14. Okay, let's have something like 10 minutes, 12 minutes. We come back and we took care of 2 more problems for you. Okay, see you then. Okay, so we are going to continue. Any questions so far? So we talk about the application of the derivative of the function, finding the equation of a tangent line, and this is horizontal line, horizontal tangent line. This is where the slope is 0, or f prime of x is going to be equal to the 0. So let's get to a kind of application problems. Okay, we talk about the kind of two types of application problems, the rate of change mostly in everyday life. So we do the one problem from physics about the moving objects. Okay, so this is, you know, in your book, they talk about quite a lot, and it's quite interesting to know. So we are going to check this one, and you have one on your test, on your practice one. Some people, they ignore this problem on the test, but this is going to be the easiest problem on the test. Okay, so don't miss it. We give you a position of a moving object, f of t, 3t squared. So minus 5t plus 10. This is going to be your position when you drive on I-5. Okay, is the position. Okay, it's going to be the position. Of course, I'll give you the unit in miles of a moving object. Okay, of a moving object after t hours. After t hours. Okay, this is it. So we are interested in average velocity and instantaneous velocity, or velocity at any time. So we usually ask, okay, so it's going to be the case. So what we'd like to do is we'd like you to find the following for us. The first part, we'd like you to find the average velocity. Okay, so what is going to be average velocity of the object? Okay, of the object over the special interval. Okay, over the interval. The interval is between 1 and 4 hours. So that would be the average velocity. Okay, this is average. And of course, the second part, they ask for the instantaneous velocity or just the velocity. Both of the expressions are going to be the same thing. So what is going to be the velocity or instantaneous velocity? So this is going to be the velocity, okay, of the object. Velocity of the object after 5 hours. After 5, okay, 5 hours. So that would be the first one is going to be the, okay. So the first one is going to be the average velocity, and the second one is going to be the instantaneous. Instantaneous velocity or velocity at the time is the derivative. Okay, is the derivative, and the second one, the first one is just the average velocity. Okay, so straightforward. You already got the formula for both of them. Okay, are you ready? The first part, average velocity is just like this rope. So solution is going to be solution, the first part. So go for the formula, you know that. You want it on this interval, so you have to find what is going to be f of 4. Okay, f of 4 minus f of 1 divided by 4 minus 1. Okay, this is going to be the average velocity as we talk about it. So basically your function is given to you. So the function f of t is equal to the 3t squared minus 5t plus 10. Just go and find it one by one, carefully plug in f of 4. So we are going to find f of 4 Your substitute is going to be 3 times 4 squared. Okay, minus 5 times 4 plus 10. So 4 squared would be 16. 16 times 3 would be 48. Okay, 48 minus 20 plus 10. Okay, so that gives you 38. 38 miles. This is the first one. And then find the f of 1. So we're going to find f of 1. We just substitute. So that gives us a 3 minus 5. Okay, 3 minus 5 plus 10. So that gives you, okay. So we find this one, which is going to be 8. Okay, so we get the 38 and we get the 8, go back and substitute in the quotient that we have. So the average velocity. So average velocity is going to be the difference. We get the 38 minus 8 divided by 4 minus 1. So on the top, we get the 30 over 3. The result would be 10. But we need, okay, we need the unit. The top is the distance is in miles. Okay, so the miles per hour. So that would be the average velocity that we have. Okay, any question? So for the first part, you just don't need any derivative. Okay, you don't need any derivative, and just do it right away. Okay, so this is going to be the first part. Any question? So don't miss it. That was the average velocity. Now the second part, they ask for the velocity. You know that the velocity or instantaneous velocity is just a rate of change or just a derivative that we talk about it. Okay, so the second part. Okay, so the second part, you have to find what is f prime of 5. Okay, so what you have to do is you have the function over here, you differentiate it and replace the t by 5. Straightforward, just make sure you know the difference. The first one is just the average, the second one is instantaneous. Okay, so find what is going to be f prime of t. Okay, this again, your function is this one, f of t equal to the 3t squared minus 5t plus 10. Now we differentiate it, f prime of t. What's going to be f prime of t? Anybody wants to try?
60 minus 5.
It's going to be 60 minus 60 minus 5. 60 minus 5. Okay, very good. We have a, okay, so 60 minus 5, you replace the t by 5. So that gives f prime of 5, which is going to be 6 times 5 minus 5. So that gives you 30 minus 5, which is going to be 25. Okay, but you have to give us the unit. So again, it is going to be 25, and that's a miles per hour, and with that. Okay, so this is going to be the case. Any question? So again, it's a straightforward problem. Okay, it's a nice application that we're going to have, and don't miss it to get these numbers. So the first part is straightforward. The average velocity is like the slope. Remember, this is the slope of the second line, and the second one is just the rate of change. The rate of change would be the derivative, and we just find the derivative of the function, and then we substitute. Okay, any question? So that would be our first kind of application category that we're going to have. You have some problems in your book. So we pick, we pick one of them, just do it when you're doing your assignment. Get to know these type of functions. And for the test, really, you have to do this type of problems first because they are pre-designed. We cannot do anything about it. It's going to be a moving object. The position functions are easily differentiated and do the job. Okay, any question? So that's a type 1 of the rate of change problem. We have another one. The type 2, we create something from business, biology, chemistry, okay, and would like you to give us your interpretation of a notion of the rate of change, like the one that I did the other day, okay? So the one that I'm going to give you is going to be a cost function because easy to understand, but you may get something from, something from biology, something from physics, not from physics because the physics is just the derivative that we talk about, okay? So let's check this one too. Again, this is going to be an easy problem to handle and to enjoy the concept. So the second application problem, again, the similar one, the practice one check. So what's the problem? We are going to give you the cost function and we ask you to find the kind of rate of change in this form. So suppose the total cost, okay, the total cost in dollars, of course, total cost in dollars of producing let's say X number of cars. X number of cars is given by, again, the equation would be given to us since this is from everyday life. So, the actual one, you may get involved with some fractions. Okay, so be ready for it when it's given to you, but it's just straightforward for this one. The cost of producing X number of cars is C of X, which is equal to the 5x squared minus X plus 10,000. Okay, that's a kind of model or a mathematical modeling for producing X number of cars. Okay, so we are going to ask 2 questions. The first part, we want to see your understanding of this concept again. So the first part, we are going to get a level of production, cost for the level of production. So we want you to evaluate, evaluate what is C of 50 and explain it in word form, and explain its meaning for us. It's going to be a straightforward application of the calculator, give you the result. The second one, a similar question, but we did derivative. So in the second part, we would like you to evaluate again, but this time evaluate what is C prime of 50. And explain its meaning. And explain its meaning. The first part is the exact value. You know that it's easy to find. You just substitute. You go to that function, to that equation, replace X by 50 and find it. Again, the actual one would have some decimals involved, like the one that we already posted for you. So there you are. Solution. The first part, substitute. What's going to be C of 50? We are going to substitute, it's going to be 5 times 50 squared. Minus 50 plus 10,000. Okay, 5 square, 250 times 5. Okay. So this is going to be, I think it's at 12,000. Okay, it's going to be 5 times, I just tried, 2,500. And this is going to be minus 50 plus 10,000. So it's a 5 times 25, 125. Okay, and the 2 zeros here. And that would be minus 50 plus 10,000. So that would be 12,500. So once get to the, make it to the 22,500 minus 50. And the result is going to be 22,450. Okay, so C of 50 in going to be in dollars, $22,450. This is C of 50. Okay, so just a substitution. Okay, what's the meaning of this one? You have to give us a in word form. Anybody want to try? C of 50, $22,450. Remember, that's a cost function. Cost of producing X number of the cars is given to you. So C of 50 would be what? Would be total cost of producing 50 cars. Okay. So this would be the expression is going to be the total. You have to explain it in word form. The total cost of producing. The total cost of producing 50 cars is going to be, well, that's it, $22,450. Okay, that's very cheap car. So that would be the first part. Okay, so you have to find it and just give us explain it. Yes, to produce 50 cars, it costs. That's Leila, you're right. You get these numbers. Any question? So that's the first part. This is algebra. Okay, that's the exact value. So the second part, remember C prime, rate of change, derivative is the future, is the prediction. Okay, so this second part. So C prime of 50, you have to find C prime of X first, differentiate this function. Okay, so you have the function. So this is going to be your function. You have to find the C prime of X first. Okay, what's the C prime of X? Derivative of the function.
10x minus 1.
That's it, excellent. 10x minus 1, 2 times 5, 10, 10x minus 1, very good. Now we want it at 50, so find C prime of 50. C prime of 50 is going to be 10 times 50 minus 1. Okay, so that would give us 500 minus 1, which is going to be 499. Okay, so in that case, C prime of 50 in dollars going to be $449. Okay, so that would be C prime of 50. Remember, C prime is the rate of change, is the future. Anybody wants to try? What does it mean in word form?
The cost of making the 51st car.
Yes. You didn't finish it.
Oh, well, that's all I had to say.
No, it's not the exact cost.
Okay, the additional cost.
No, that expression is correct. That when we get is not exactly. Okay.
Oh, is it the approximation?
Yeah, that's one. Yeah.
Okay.
It's approximately $499. Yes. The other one is like the one that we did, Leila. That's it. Remember, this level of production is important. After producing 50 cars, yes, you are right. The cost of production will increase by $499 per unit. Yes, that's it. That's the best way to write it down. So yes, two different one. The one that Ben talk about it is exactly the future. The cost of the next additional one. We already done with the 50 car. If you want to do the next one, this is going to be the change in cost. So that would cost approximately about $499, because this is not the exact, you have to use expressions, about, approximately. Or the other one is just emphasizing, you see, the easy one for all of them is we study this level of production, because that would be the prediction. So as Leila talked about, it's going to be after producing 50 cars, the total cost, since it's positive, will be increased. If it's going to be negative, decrease, will be increased. Okay, increase at the rate of $499 per unit. Okay, per unit or per car. That's the expression that we can use for all of them, because the rate of change is a prediction. So you have to put it in the format that shows us you are going to predicting something, okay? Or equivalently, this is another option that Ben talked about it. Equivalently means the cost of producing an additional, or the next one, additional unit or car is approximately or about approximately $499. We don't say is, because is would be the exact. You're just predicting what would be the result. Okay, so be prepared for it. We are going to give you a situation that you have to describe for us. Okay, there are some from biology about growth, decay. We can talk about the temperature. Okay, different units. So you have a nice one on the test that you describe, and that give you better understanding really of what is really the meaning of the derivative of the function when you're dealing in everyday life. See, I call it, remember the other day, I call it predicted rate of change. So that would predict the future for us, okay? So that give you an idea how to write it down precisely so that you're going to get good grades, okay, full credits, and again, enjoy and, okay, understand it to get these numbers. Okay, so we did all sorts of applications. From geometry point of view, it's the slope. So that will help us to give us a equation of tangent line. So from that point of view, if you stay with that point of view, then horizontal tangent lines are going to be the targets, because those would create the maximum and the minimum. But if you are going to be in everyday life, is all the problem of a rate of change and prediction. So the rate of change in displacement will enable us to define the average velocity and the instantaneous velocity. And for everyday life, this is the prediction that we're going to do. When we have a rate of change, you get a growth of the cancer cell, for example. If you know this idea and what would happen in the next 6 months, that will help you to start, prevention, applying some drugs, etc. So this is the way we're going to operate with the derivative of the function, not just all abstract terms all the time. Okay, so that would give us the application problems. Any question? No. we stay with the same line, if you like, to go on. We like to bring two other formulas, but before going on, we have to take care of one more problem, and that will give you another problem for the test. You see the notion. I've already talked about it, but we haven't made it official. This is going to be our next problem that we are going to consider. And again, it's part of 2.2. It's a very dense section. We want to know what's the relationship between continuity and the differentiability. Remember, a function is continuous if the graph of a function is one piece, no holes, no gaps. Okay. And the function is differentiable, of course. You know that the function is differentiable if you can find a tangent line, if you like, okay, from geometry point of view. So the relationship between these two are going to be clear. That, for example, if the function is going to be differentiable, okay, then there is a tangent line at the point. When there is going to be a tangent line at the point on the graph cannot have a gap or a hole at that point. So the function automatically would be continuous. So differentiability, applies continuity. But the converse is not going to be true. So I'm going to give you this officially. What's the relationship? Then we give you one function and we ask you to check it. It's mostly for a piecewise defined function. And you get one question on this on the test again. So, and these relationships are going to be very important for future. If you take calculus 3, this is going to be one of the challenging problem that you have to consider, okay? So what is going to be a relationship between? Okay, we make it official and we give it that problem, okay? What is going to be a relationship between a function to be continuous or a function to be differentiable? Between differentiability, okay? Between differentiability, that is one, and continuity, and continuity. Okay, that's going to be the one. And the main thing that we know is, as I talk about it, if a function is differentiable, means there is a tangent line. If there is going to be a tangent line, that function must be continuous. So this is a fact. We make it as a theorem. Okay, so what is going to be this theorem? Okay, the theorem is going to be, that's it, if a function f is differentiable. As soon as they say differentiable, it means there is a tangent line at the point. So if there is a tangent line, there is no hole at that point. The function is continuous at that point. If a function f is differentiable at x equal to the a, okay, then f is continuous. F is continuous. F is going to be continuous, okay, continuous at x equal to the a. Okay, so this means differentiability implies continuity. Okay, continuity. So if the function is going to be differentiable, it is continuous. Okay, although it's clear, I prove it for you. You can prove it in one line. Okay, it's not bad to see the proof. Okay, are you ready? But from geometry, when it's a differentiable, you see, when it's a differentiable means there is a tangent line to the graph at that point. So when there is going to be a tangent line, the graph cannot have a hole, continuous. Okay, but if you like to see the proof, we are not going to ask you, of course, to prove it for us. bad, not bad, to see how easy it is. Suppose it's differentiable. Suppose f is differentiable. Okay, differentiable at x equal to a. You know that would follows that this limit does exist. F prime of a is equal to, remember, the limit of x goes to a, and you have f of x minus f of a, x minus a. That's it, tangent line. So what you should prove for continuity, you should prove the limit, you see, 1 or v. One should prove that you should prove this one. The limit of f of x goes to a is f of a. That's the definition of continuity. Okay, connect them together. How are we going to prove it? Look at this one. Note that I'm going to estimate the difference between these two. I show that the limit is 0, the limit of a difference. So look at the difference, f of x minus f of a. So to connect it to the derivative, I'm going to divide this expression by x minus a, and at the same time, I multiply it. So I divide it first, f of x minus f of a over x minus a. Then at the same time, I multiply it. You see? Because these two would cancel out, so I'm not going to miss anything. Somebody may say, oh, you can't do it. The denominator cannot be 0. I say, okay, x is not equal to the a. I assume this one because we want to take the limit and you don't need it. Now take the limit of both sides. So what's going to be the result? Take the limit. If you take the limit of this one, it's going to be f of x minus f of a, x goes to a. Is the limit of the product of two functions going to be limit of the first one, limit of f of x minus f of a over x minus a, x goes to a, times the second one, the limit of x minus a, x goes to a. You see? I take the limit of both sides, okay? It's a product of two functions. So it's going to be limit of the first one times the limit of the second one. But the limit of the first one is the derivative. So this first one would be f prime of a. Limit of the second one, you just substitute. So that give you a minus a. But a minus a would be 0. So that give you f prime of a. Okay, times it by 0, which is equal to the 0. That's it. So you prove that the limit of, see, so you prove that the limit of f of x minus f of a, x goes to a is 0, which conclude that the function is continuous. Limit of f of x, x goes to a, is equal to the f of a, and f is continuous. F is continuous, okay, at x equal to a. That's it. So if a function is differentiable, again, if the function is differentiable, it means there is a tangent line. When there is going to be a tangent line, of course, when there is a tangent line to the graph of your function, so in that case, your function cannot have, the graph cannot have a hole, cannot have a gap. So the function must be continuous. Okay, so differentiable functions are going to be continuous. Any question? But the difficulty is going to be the converse. You see, the converse is going to be if the function is differentiable, we prove that it's a continuous. The converse is if a function is continuous, does it follow that that function is always differentiable? The answer is no. Okay, that was the problem that they didn't realize this one in calculus during the early years because they were working with the polynomials all the time. And you know that polynomials are nice. Polynomials are continuous and are differentiable. But the situation are going to be this one that you are not going to see it. Okay, any question? So differentiability give us the continuity, but the converse is not true. And that is the problem that we're going to check for us. So remark. The converse of that theorem is not going to be true. Okay. Oh, there is one version that we are going to use. Give you remark number one. You see, and the way you are going to use this one on the problems are going to be kind of logically, there is another version of this problem. You see, this problem will tell you that if f is differentiable, then f is continuous. So equivalently, this means if f is not continuous, then f is not differentiable. Okay, in logic, each of them would be called a proposition. And there is something equivalent that we are going to have. Okay, so we call it contrapositive. So that would be very, very useful for you in there. This is the way you're going to use this one. So let's make this one first. You see, note that if a function by the above theorem, if a function is not continuous, You see, you don't need the theorem. You know it. Is not continuous at x equal to the a. You see, if it's not going to be continuous at x equal to the a, means the graph of the function would have a hole at a gap. If there is going to be a hole or a gap, you cannot have a tangent line. So if you cannot have a tangent line, means the function is not differentiable. Okay, so if a function is not continuous at x equal to the a, then f is not differentiable. Not differentiable. And so f prime of a does not exist. That would be so useful for you. So you are not going to use this version of the theorem. Okay, you are going to use this version of the theorem all the time. So if your function is given to you, so look at this one. If you have this is going to be the graph of your function, for example. You get a graph of your function, okay, and like a piecewise defined function. You see, look at this one. So at this point, you see, at this point there is a gap. There is a gap. Is this continuous? So at this point, you cannot have a tangent line because this is going to be the breaking point here. So f prime does not exist if the function is not going to be continuous. Okay. So this is one version that we're going to use. The other version is, you see, this is where the function is not continuous. Now the question is going to be, if the function is continuous, can you conclude that the function is going to be differentiable? So the converse of the theorem is not true. Not true in general. So this means if a function is continuous, if a function is continuous at x equal to the a, then you cannot say that f prime does exist. Then we cannot conclude that f prime of a exists. You see, if you are going to be, if the function will continues, there are two different cases. Look at this one. Look at this graph. Look at this. This function is continuous because it's one piece. And there is no gap. They cannot have a gap, of course. There is no sharp corner. You see, because at any point you are going to have a tangent line. You see, anytime, any point you consider, I can have a tangent line everywhere I like, because there is no sharp corner. So this function is continuous and is differentiable. Okay, so that's case one. The function has no sharp corners and is differentiable. Okay, that's the first case. So if the function is continuous and there is no sharp corner, it's also differentiable because you can have a tangent line. But the difficulty is this second case. Look at this one. Look at this graph. It's continuous because it's one piece, but you get lots of sharp corner. Look at this sharp corner, sharp corner, sharp corner, sharp corner. So at this sharp corner, you cannot keep a tangent line here, you see? You cannot keep the tangent line here because it's a sharp corner. So this graph is continuous, but there are many, many points where the function is not differentiable. Okay, so this graph, the function is continuous and contains, if you like, sharp corners. Sharp corners where the function is not differentiable. Not differentiable. You see, so that's a difficulty in calculus when you're dealing with the functions. So this is a situation that you are going to have. Look at this. If the function is discontinuous, there is a gap here, you cannot have a tangent line. So discontinuous, non-differentiable. But if a function is continuous, you have two cases. It may be, we call it a smooth curve. The curve has no sharp corner. So it's a continuous and differentiable at the same time. And you may get a sharp corner. If you get a sharp corner, as those sharp corners, the function is not going to be differentiable. So that's why you are going to have two different cases. The case that your function is not continuous, that's a straightforward, not continuous, no differentiable. But the case that it is continuous, you have to check it. You have to check to see, is it the first type or is it the second type? So that gives you a relationship between continuity and the differentiability. A mathematician or the people in calculus, they were surprised that I wanted to talk about the Carl Weierstrass. Weierstrass, they create a function that surprised everybody. I'm going to show you that function. You see, Weierstrass. Everybody take calculus 1 or calculus should be familiar with this function. If you are going to be a math major, you will see this function in future again. But if you are any other measures, you will see this function in some other purposes. You see, he surprised everybody. He find a function like this with lots of sharp corners. You see, this function would have some places that you can have a differentiability tangent line. But he find a function that is continuous, but it got so many sharp corners. That function is never differentiable. It's a very famous function. So this is, there is a function. There is a function. It's a very unique function. There is a function that is continuous. That is continuous on R, and is nowhere differentiable. Nowhere differentiable. You don't even have one point on which the function is going to be differentiable. This would be, he surprised everybody. We call it everywhere continuous. Everywhere continuous. Nowhere differentiable. Nowhere differentiable. Differentiable function. It's a great function, Weierstrass functions. Okay, let me just, if you search on internet, you will see the Weierstrass function right away. Okay, let me show that Weierstrass function, then we come back, maybe tomorrow I give you one example, the way we are going to question you on the test. Okay, any question before going to searching for that function for you? So that is give you a nice idea of what's continuous and differentiability means. So just think about it from a geometry point of view to remember it. Geometry tells you that if a function is differentiable, there is a tangent line. So if we cannot find a tangent line, the function is not differentiable. So if the function is not continuous, there is a gap. You cannot find a tangent line here, so the function is not differentiable. That's an easy question. But if the function is continuous, you are in trouble. You have to check it. You may get the continuity or you may get not, or you may not. So you check it, it may be a smooth curve, no sharp corner. So we get differentiability, but you may get some sharp corners. If you get a sharp corner, the function is not differentiable. So you cannot make a general statement to get this one. Let me check if I can give you that famous function. You can check it for yourself, but any question? So, that is, if you go on internet and check, let me share that part with you, so to see how we are going to find it. Go to the basic part, and this is where I get the Weierstrass function. If you just check Weierstrass, okay, let me just check. And that is going to be as soon as you check the Weierstrass function, you will see it. Can you see the one I'm sharing from internet? So if you check the Weierstrass function, this is going to be the function that you have. Just check to make sure that you're sharing the correct one. Okay. Yeah, if you know, if this is, if you get a sharp corner, in that case, the function is not going to be differentiable. Everybody can see this. You see, this is going to be the Weierstrass function. It was an animation. I want to get that one. Is what? Where is the function? Yes, that's the one. Can you see it? You see, this is the situation you're going to have. This is the Weierstrass function. So as we move on, you get lots of sharp corner over here. At those sharp corner, you are not going to have any tangent line. Of course, the equation of this function is not going to be easy to work with. Let me see, where is the equation of the function? You see, as you move on, these points would be repeated over and over, but the function never is going to be separated. But you get so many of these sharp corners. Just want to bring the formula for you. Look at the formula. This is the formula for the Weierstrass function. We are giving as we call it a series function. You are going to be a math major, when you want to, before you graduate, then you can prove that this function is continuous as an over differentiable. So we change this a and the b, and we are going to get it in different steps. So as you move on, we change the a and the b, so we get lots of sharp corners. You know that if the graph would be repeat itself, today, in the language of today, we call them fractals. So that's going to be a special function, fractal. You know that the fractal, and there is something we call it the chaos theorem in mathematics, and the Weierstrass function happen to be related to this type of ideas. It surprised everybody because when the function is differentiable, f prime is a rate of change. It's a growth, it's a velocity. So they find out that this function is nice. So there is a kind of growth, but when it's not differentiable, so it's a kind of a paradox. But there is a special growth in biology. They call it Brownian motion. So the Weierstrass function was a proof, or was a mathematical design for those type of ideas. And there is also one in a statistic. So that's why we wanted to know this function really, that get to know it, search it for yourself, and to enjoy it, and to see what is going to be this idea. Okay, just going back to my note again. Right, so what's going to be your job? Your job is, we give you a function and we ask you to check it for us. The function, of course, is not going to be a polynomial. Okay, it's not going to be a polynomial. It's going to be a kind of a piecewise defined function. I don't have time, so I give you this function tomorrow. So we give you one question on this. It's going to be two functions. The first one is you are lucky when you check it, it's not continuous. So f prime of a does not exist. The second one is where the function is continuous, and then you have to check the second part. So it's going to be two functions. I'll talk about it tomorrow. So you get one question on the test. We give you a piecewise defined function, and we give you two functions, in fact. So one of them would satisfy the first part, and the other one the second part, and then we're done. Okay, so we did talk about quite a lot. So start working on that practice test that you have. What we are going to do tomorrow is we are going to discuss two more rules. That would be the product rule and the quotient rule, and the derivative of the trigonometric function. And this is where we are going to finish it. Okay, any question? So 11 questions on the test. 5 from the quiz, 6 from whatever I did today, and I'm going to finish it tomorrow. I've already given you 4 problems, so I need 2 more. I give you that 2 more tomorrow, and then I can do some of the problem, and I post the solution for that practice test as well. Okay, study this one carefully. Any question? So have a good one and see you tomorrow. Start working that practice test. Okay, bye-bye. Thank you.